Okay, if you're watching this video and you're in my grade 8 math class, you're probably at home right now, the night before your test, which is tomorrow, panicking because you're not sure how to model fraction operations. But don't fear. If you understand these 5 questions that I'm about to do with you, you will do swimmingly on your test tomorrow. The first question says 3/4 times 2. And the way we model that is very simple. We have to draw 3/4, which up until now we've always used beautiful rectangles and colored it in. So that, ladies and gentlemen, is what 3/4 of an object looks like. And if I double it, which is multiplying it by 2, all I have to do is draw it twice. Now, if you think back to 6.1 when we did this question, the question you have to ask yourself to get the answer is, how many quarters do I have in total? So before I actually do any work, I'm going to put this down because I know I'm really counting how many quarters there are. And I have 1, 2, 3, 4, 5, 6 quarters, which is my solution as an improper fraction. As a mixed fraction, it is 1 2/4. And as a mixed fraction in lowest terms, it's 1 1/2. Now, what I advise you all to do on your test when you have the modeling part is just have a little area here and you put in the check my work. So you go 3/4 multiplied by 2, or 2/1 equals 6/4, which equals 1 1/2. So when you check your work using an actual algorithm, that's the work you would probably show to prove that you were indeed correct with your modeling. So your next question is 3/5 divided by 2, which is very similar to the chocolate bar question that we did with the plane crash. You will start by drawing 3/5, and I drew this very poorly, so I'll have to start again. 1, 2, 3, 4. Shade in 3/5 as such. Now, if I'm dividing it between 2 people, divide it right down the middle and just put 2 names here. I'm going to put my name and my wife's name. And we're going to share that 3/5 of a chocolate bar equally. What's my denominator right now after I make that cut? It's 10. There are 10 parts. And how many pieces of chocolate do I get? 3/10. So if you have 3/5 divided between 2 people, the answer is 6/10. Now, another way to think of it, and we talked about this before, if 3/5 as a percentage is 60%, and if I just briefly think to myself, is 60% divided by 2 30%? Yeah. So then, therefore, my answer as a fraction makes sense because that is also 30%. If you wanted to check your work, the word check up here. 3/5 divided by 2 is the same thing as 3/5 multiplied by the reciprocal of 2, which is 1/2. And when I multiply that, I end up getting 3/10 as my answer. Our third question says 2/5 times 3/4. Now, does anyone have a hint for how somebody who struggles with this question could always get the right answer if they do this every time? What would you say? What I would suggest is you read it as the word of. So if I say 2/5, and instead of saying multiplied by, say of, because these are really the same thing. 2/5 of 3/4. If I write that down, it's pretty hard for me to screw this up, because I'm going to say 2/5 of 3/4. I'll draw my 3/4. I wish I had a bigger marker. I wonder if I could change the size of my marker. Yes, I can. I can go actually bigger. Look at that. So 3/4. Well, that's much better. That is 3/4. Now I want to keep 2/5 of it, so I'm going to cut it into 5 parts. 4 cuts doth 5 parts make. And I'm going to keep how much of it? How many fifths? 2/5, which is 1 check mark and 2 check marks. So what is my denominator after I make said cuts? There are now 20 total parts to that chocolate bar. And how many parts do I get? 6/20. Is that lowest terms? No. So in lowest terms, my answer is 3/10. Check your solution. And that's really easy. This is the easy one to check your solution because all you have to do is multiply your numerators to get 6/20, which equals 3/10. So my answer is correct. My drawing is correct. Your fourth question gives you a mixed fraction multiplied by a fraction. And for all mixed fraction multiplication modeling, we are going to use what type of model? It's called an area model. So we shall make an area of a rectangle. My mixed fraction will be broken up into two parts. From this dot to this dot will be the whole number of 1. And from this dot to this dot will be the fractional part, 3/4. So if you can visualize it, that red line's total length would be 1 3/4. Everyone agree? If I put 2/3 over here, then this total length is going to be 2/3. And we know from our experience with rectangles that area is length times width. But rather than do the entire length of 1 3/4, I'm going to break it up into two smaller parts, into an A area and a B area. And A plus B will equal the total area of the rectangle. So therefore, the length of A is 1 and the width is 2/3. The length of B is 3/4 and the width is 2/3. So if I figure out what each of those answers are and add them together, that should be equal to the entire product of 1 3/4 times 2/3. So 1 times 2/3 is easy because multiplying by 1 just keeps itself. If I do this one, you could get 6 over 12, but when you cross reduce, that becomes 1 over 1. That becomes 1 over 2. When I do that, I get my answer of a half for that. And A plus B will equal the total area, or 2/3 plus 1/2 will equal the total area. What's my common denominator? That's right, it is 6. 4/6 plus 3/6 when adding. Add your numerators and keep your denominator. My final answer is 7/6, which is 1 and 1/6 as a mixed fraction. Okay, how to check my answer? Let's do a check over here. Check. So it's 1 3/4 multiplied by 2/3, which is 7/4 multiplied by 2/3, which is 14 over 12, which is 1 2/12, which in lowest terms is 1 1/6. So for the last question, we have a mixed fraction times a mixed fraction, and when we have mixed fractions in our product, we're going to use an area model. This will be 2 3/4. This will be 1 1/2. Here we have 4 composite areas that make up the entire area. What's the length and width of A? 2 times 1. What's the length and width of B? 1 times 3/4, or 3/4 times 1. The length of C, 1/2 doubled. And the length of E is 1/2 times 3/4. This should be easy, because I think 3 of them are going to be really easy. What's 2 times 1? There's your area of A. What's 3/4 times 1? Just 3/4. What's 1/2 doubled? Just 1. And finally, the last one, what's 1/2 times 2? What's 1/2 times 3/4? 3/8. Am I done yet? No, because now I have to add the sections together. Now the commutative property and the associative property of mathematics says the order in which you add or multiply does not affect the product or sum. So if it doesn't matter which ones I add first, which ones do you think I want to add first? No, I'm not first. I'm going to add this one and this one. What does that work out to be? 3. So 2 plus 1 plus 3/4 plus 3/8. Add those two, bring it down here. Now I'm going to worry about my fractions. Common denominator is 8. So instead of saying 3/4 plus 3/8, I can say 6/8 plus 3/8, which is 9/8, which is equal to 1 1/8. What do I have to finally add that to? 3. And my final answer, therefore, equals 4 1/8. Is that right? Did I do that right? Right. Check your work. If I check this, am I actually going to use mixed fractions? No. I'm going to go 3 over 2 multiplied by 11 over 4. I'm just going to change that to improper, which is equal to 33 over 8. How many 8s are there in 33? There's 4. That's 32 eighths. But since I have 33 eighths, that's an extra 8 left over. My final answer is indeed correct, 4 1/8.